Welcome back. So we're ready for our second section, Module 1, Lesson 2. In this section, we're going to learn about different ways to model positive and negative numbers. We're going to use number lines, we're going to use chips, we're going to use money, and then last we're going to use the rules, which most of you were taught when you were in school. But the reason we try to use multiple ways is because a lot of students say, oh, I forget the rules for positive and negative numbers. Well, if you know multiple ways, then there's a good chance you'll remember at least one of them. When you just know one way, it's easy to forget. So we're going to start with the number line. So plot the numbers that correspond to the given situations. When we plot a point, we use a dot to mark correctly, because I'll see some students like circle it. Plot means we actually need to place a point at the correct location. And label all surrounding tick marks. So Bill lost a $10 bill in the wash. So since he lost $10, that would make it negative 10. And we could choose to go by ones, we could choose to go by twos, we could choose to go by fives. In this case, I just chose fives. And so then we plot the point, negative 10 with a dot. And that's the change in Bob's money in dollars. He lost $10. So next we have Tom gained 4 pounds. Well, this one would probably be easy enough to do by ones. So 1, 2, 3, 4, 5. And we'll just put a couple negatives there. We don't need to fill them all in. And he gained 4 pounds. Gained means his weight went up. Therefore, that would be a positive 4 pounds. So his change in weight is positive 4. And then we can do the opposite scenario. Angela lost 4 pounds. So that would be negative 4. So we could do the same thing, do a couple on the positive side, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Lost 4 pounds would be placing a point at negative 4. So notice I don't say he lost negative 4 pounds. We use words in place of the negative. So I would say she lost 4 pounds, or her change in weight is negative 4. So we use words like lost and gained to show the sign of the number, rather than when we're writing in words, we don't use the positive and negative. We use words that mean those. So a temperature in Minnesota today is negative 2 degrees Fahrenheit. So that one's pretty easy to figure out because it's negative. So we could start here and do negative 1, negative 2, negative 3, negative 4, negative 5. Couple over here, and plot the point at negative 2. So the temperature in Minnesota is, if we are saying it in words, the temperature in Minnesota is 2 degrees below 0. So we use the word below instead of the negative sign when we're writing it in words. Camille spent $6 on her debit card, and sometimes students have a little bit harder time with this one because they spent, but you got to look over here and it says her change in her account balance. So her balance went down $6. So spent would be negative. So this would be a good one maybe to do by twos. Negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, and then we can do 2 and 4 here. As long as we're consistent, we can count by whatever we want. So I'm consistent the entire length of the line going by twos. So spent $6 would be her account balance went down $6, or decreased by $6. So I don't say decreased by negative 6, just like you wouldn't say, oh, I went to the casino and I lost negative $20. You use the word lost instead of the negative. I went to the casino and I lost $20. So in words, we do not use the positive and negative. We use words that mean positive and negative. Carlos snorkeled 40 feet below, there's the key word there, the surface of the water. So this one looks like maybe a good one for tens. So we could do 0, 10, 20, 30 here. And on this side we could do -10, -20, -30, -40, -50, -60. And he's 40 feet below, so we place our point at -40. So when we're saying that in words, we could say Carlos was 40 feet below the surface of the water. Carlos was 40 feet deep. Words like that, rather than saying he was -40 feet underwater. We would never say that because under the surface is the same thing as saying negative. Okay, so that gives you a little idea on words we can use. Okay, I'd already crossed that one out. We're not going to make up our own. I hope you guys can forgive me for that, but I just like to do the math. I'll leave the creativity to you guys. Okay, so on this page, we're going to find the absolute value, which is also called magnitude or length of numbers using the number line. So absolute value is, the definition is a number's distance from 0. And that's what magnitude is, the length or the distance of something. A number's distance from 0. And distance is always positive, because you wouldn't say, oh, I live -5 miles from the school. No, if we're talking about a distance, it's always positive. So anything that comes out of absolute value symbols, which look like this, will come out positive, because that means take the distance that number is from 0, or state the distance that number is from 0. So here we had Bob lost a $10 bill from the other page, and that would be interpreted as -10, because he's $10 poorer than he was before, or he has $10 less than he had before. So those are words that would mean the negative. To do the absolute value of -10, we put the bars on either side. And how many units is -10 from 0? 10. So this is its distance from 0, and like I said, it will always be positive. So those little lines are read absolute value. I should put that up here so you can highlight it to remind yourself later, because we do deal with absolute value several times in this class. So there's absolute value, those symbols. Word that describes the magnitude would be lost, or less $10, or whatever you wanted to use. What does 0 represent in this context? A change of $0. He would lose or gain $0. So Tom gained 4 pounds. So we know that is +4 for the number. Its absolute value would also be +4. Some people think, oh, every time I see those symbols, I change the sign. Not true. The answer's always positive when it comes out of the absolute value signs. So a positive comes out positive, a negative comes out positive. A word that describes the sign of the magnitude would be gained 4 pounds. That's how we know it's a positive number. What does 0 mean in this context? It would mean gained 0 pounds. And then we can do the same with the negative, the absolute value of -4. Again, always positive, so it's +4. A word that describes the sign would be lost 4 pounds. That's how we know it's negative. So lost 4 pounds. What does 0 mean? Lost 0 pounds. I don't know, that third one is kind of redundant, but sometimes it makes, you'll see on this next one, sometimes it makes a little bit more sense, but why do they keep asking that? What does 0 mean? No change. The temperature in Minnesota is -2 degrees Fahrenheit. So the absolute value of -2 is +2 because numbers come out as out of absolute value always as a positive. Now this is the one sometimes students struggle with. What word? Well, think about how we say it. Oh man, did you hear it's 20 degrees below 0 in Iowa? That would be a description of a negative thing, so below 0. So it would be 2 degrees below 0 whenever it's a negative. What does 0 represent in this context? 0 degrees Fahrenheit. Okay, I'll let you guys do the next two, so shut off the recording, do those two, and then turn it back on and we'll check them together. Okay, Camille spent $6. We said that means her bank account balance went down 6. That's why the -6 is there. The absolute value of -6 though is always +6. What's the word that makes us know that it's negative? Is spent $6. What does 0 represent in this context? It would be spent $0. And last but not least, so here's Carlos snorkeling again. Since it's 40 feet below, we know that means -40, but the absolute value of -40 is still +40 because absolute value is always positive. It's a distance. What word describes that? 40 feet below the surface. And what does 0 mean? Oh boy, that's not even a 0. Somebody typed in small o. What does 0 represent in this context? You would be on the surface. Or you could say at sea level. Whoops. Everybody do okay on those two? Not too hard, right? Okay, on the next page, I have the first one crossed out because we didn't make that problem on the other page, which is referring to that. But I do want to do the other two because I know these are on your test, so this would be a good time for a highlighter. Okay, what do you notice about the absolute values of 4 and -4? So the absolute value of 4 and the absolute value of -4, I think you all know they're both equal to 4, right? Why is that? Well, look at a number line. 1, 2, 3, 4. 1, 2, 3, 4. If absolute value means a number's distance from 0, 4 is 1, 2, 3, 4 units from 0. Negative 4 is 1, 2, 3, 4 units from 0. That's why they're both the same answer, because they're both 4 units from 0, just on opposite sides. We can just say they're the same. Same distance from 0. Maybe that's what they want. Gonna have to restock up on my pens. My pens are running out. Okay, so next we have absolute value bars work similarly to parentheses. That means do me first. Remember, please excuse my dear Aunt Sally always says parentheses come first. So we always do what's in absolute value bars first, just like parentheses. Using this idea, what do you think of the following expression? So because please excuse my dear Aunt Sally says do parentheses first, and absolute value are grouping symbols just like parentheses, we basically are just covering this up. And we're saying, what's the absolute value of negative 4? And we just wrote up there that it's 4. So I bring that down, uncover this, and bring it down. This is read, by the way, the opposite of the absolute value of negative 4. Well, the absolute value of negative 4 is 4, and the opposite of 4 is negative 4. That's the official way to read that. The opposite of the absolute value of negative 4. So absolute value negative 4 is 4, and then we bring the negative down. So our answer would be negative 4. And yes, that is on your quiz and it is on your test. So that's a good one to highlight and remind yourself to look at. Okay, and we have some on the practice test too. So you'll be able to practice some more on those. Okay, student page C. So we're going to learn about opposite, and I put these side by side for a reason, because students think opposite and absolute value are the same thing, and that is absolutely incorrect. When we do the absolute value of negative 4, yes, we do take the opposite. But when we do the absolute value of 4, it stays the same because they're both 4. So we cannot call absolute value opposites. Opposites mean you automatically change a sign, and we don't automatically change a sign on this, only for the negative numbers. So this is not considered opposites. It's called making your answer positive. Opposites is where you automatically change a sign. So the opposite of negative 10, if you're 10 units to the left of 0, the opposite would be positive 10, which means you're 10 units to the right of 0. So opposites are two numbers that are reflected about 0, same distance on either side of 0. So the opposite of 5, 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. So the opposite of 5, we go to the other side, 5 units away from 0, and there we are. So the opposite of 5, the opposite of 5 is negative 5. And remember, opposite just means change the sign. So you reflect it across the 0 axis, and you're on the same number of units as before. I guess I think they started with the dot there too, yeah. So the opposite of negative 6. So let's do 2's this time. So negative 2, negative 4, negative 6. positive 2, positive 4, positive 6. So the opposite of 6 units to the left of 0 would be 6 units to the right of 0. Right across that reflection line, same distance apart. So the opposite of -6, which in math symbols would look like this. The opposite of -6, as we can see, is +6. And that's where we get the phrase, anytime you have a double negative, make it positive. And we're going to learn that in a little bit. So anytime you have a double negative, you make it positive, and then we can see why that holds true by looking at this graph. Okay, absolute value of -3. So first we have to do that down here. So the absolute value of -3 is 3. So the only difference on this one is we're labeling this like that. Yes, it is 3, but it says the opposite of absolute value of -3, so we need to write it as absolute value of -3, which, if you want to put your little parentheses there, is +3. One second, I need to plug in my computer. It's given me the message. I thought I had it plugged in, but okay. Give me just a second. There we go. Okay, now we're good. And the opposite of 3 units to the right of 0 would be 3 units to the left of 0. And we would label that, remember how I said opposite? Oh, and I forgot to write that here. This would be the opposite of -6. Sorry about that, I forgot to write that here. So that's how we should have labeled that, which is, okay, the opposite of -6, yes, which is +6. So this one would be written as the opposite, because remember, opposite is written with a negative, of absolute value of -3, which we know that to be 3, and we know that makes it negative. So in parentheses, we know it's -3. Okay, so it gets a little tricky with the words, but what you have to remember is opposite means put a negative sign in front. So opposite of the absolute value of -3. Well, the absolute value of -3 is 3. The opposite, -3. Okay. I know when I'm in class, students are a little foggy on that. They're like, yeah, I definitely got to look at that in Alex. That wording's a little tricky, because a lot of them said that their teachers in high school, and when they've seen it before, never pronounced it as opposite. Okay, now are you guys ready? This one's getting really, really gnarly. Do you guys want to try it first? Yeah, shut off the camera and try that first. Okay? Shut off the video and then come back to me and we'll compare answers. Okay, so opposite means negative, and then there's another negative, and then there's another negative, and then we got to close. So the opposite of -4. And remember, we always start inside parentheses. So remember what I said about the double negative? So double negative always becomes positive. And the opposite of +4, and if you want to write it again, is -4. So does that make sense? So first we have to do this. We have to plot this. So we're going to be plotting +4, right? Because a double negative is a positive. Just like here, we plotted 3 first and then went to the opposite. So we have to plot this number first. So this is just another way of writing positive 4. Double negative turns into a positive. And then its opposite, obviously, is negative 4. And so this would be, its technical way of writing it would be the opposite of negative 4, which we know means positive 4. And this would be all that mess there. The opposite of negative 4. Which this is positive 4 inside. The opposite of positive 4 is negative 4. So we start here and we go here. So you can see they get a little bit tricky, the verbiage, but you just have to do one step at a time. Start with this. This really means positive 4 because a double negative is always positive. So 4, its opposite's negative 4. And we can see that with the math there. That turns into 4, the opposite of positive 4, negative 4. Can any number be its own opposite? Yep, there's one. That would be 0, because 0 doesn't have a sign, so the opposite of 0 is 0. Positive 0, negative 0, same thing, but that's the only number that is its own opposite. So that page you might want to look back at a little bit and just, you know, or go straight to ALEKS and practice on ALEKS. That's one of the things I tell students about being a successful math student is do your notes, go to ALEKS, work on your homework that goes with those notes. Then do your notes, go to ALEKS, work on your homework that goes with that. Because studies show that students that practice right after they learn something, then it sticks in your brain. If you take a week to do all your notes and then you go and do your homework, you're going to forget about what you learned a week ago. So you always want to make sure you have a healthy balance. Take notes, practice those topics on ALEKS. Take more notes, practice those topics on ALEKS, because that's how you get it to stay in your brain and solidify rather than forget about it and learn the next new thing. So if you haven't taken an online math class before, that's a very important thing to know, is you always should do your homework the same day you learn the material while it's fresh in your head. Okay, next we're going to represent positive and negative numbers using chips. Oh, okay. Yeah, I don't know if we're going to get all the way through this, but we'll see. So use 2 colored chips to represent the following integers in at least 2 ways. Yellow chips are positive, and red chips are negative. So when I see positive 5, and I'm just going to use plus signs and minus signs, so I know it's going to be 5 yellow chips. That would be the easiest way to represent it. 3, 4, 5. And so now you're probably going, what's she talking about? How could we represent positive 5 any way than just 5 positives? Well, there are ways. Do you guys remember that opposites attract? They also cancel each other out. So I could do 7 positives. 1, 2, 3, 4, 5, 6, 7 positives. And then I could do 2 negatives. And guess what? Ding! Ding! Gone. So my answer would be 5. And we could even make up an addition problem with that. We could say 7 plus 2 negatives gives me 5. And that's the rules that we're going to be learning in the next packet, is the rules for sign numbers, but this just lets you visualize it before you see it. Because students go, well, I don't understand how 7 plus negative 2 is 5. Well, first off, 7 plus negative 2 really means 7 minus 2, so it's easier to see why it's 5. And then here you can see with the picture, this is 7 positives because there's no sign in front, and 2 negatives. 1 positive and negative cancel, another one cancels, and what do I have left? 5 positive chips. So I like doing this before you learn the rules because it just makes it so much easier to visualize it later. Okay, so let's do 2 more and then I'll let you guys work on a couple. So negative 5, so again we could start with the standard 1, 2, 3, 4, 5 negatives. So that's just the typical way to represent negative 5. Then we could do, let's do 8 negatives. 4, 5, 6, 7, 8. And then I need 3 of those to cancel out to only leave 5 negatives left. And then I go ding, ding, ding. What's my answer? Negative 5. So again, we can write an equation about that. We can say negative 8 plus 3 is negative 5. So when I add 8 negative chips to 3 positive chips, the first 3 cancel out, and what's left is my answer, negative 5. So isn't that cool? And I tell students, if you can't remember rules on a test, draw chips. Chips are so easy to remember. And then we're going to do the number line in the next packet, and you'll see that's wonderful. Or maybe it's even in this packet. I can't remember if I think maybe in the next packet. But you'll see there's just so many visual ways to help you remember the rules. You don't have to automatically remember them. So, okay, we're going to stop there because we're at 30 minutes, and then we will start from here on the next video.